Okay, so who cares about Le Chatelier's principle and his shifts? Well, the people who are making ammonia in an ammonia factory for a profit using the Haber process, they care. Okay, so this is the example I've been using. N2s and H2s get together to make NH3, which is ammonia, which is a household cleaning product, which is sold for profit. So the people making ammonia want to use this process. So again, equilibrium says that N2s and H2s are getting together to make ammonia, but at the same time, the reverse reaction is happening in equilibrium, and those NH3s kind of bump into each other and end up turning back into, some of them turn back into H2 and N2 at the same rate. Okay, and the people making ammonia are like, I don't want that to happen. I just made this ammonia. I don't want it turning back into H2s and N2s. I'd like it to stay ammonia, and I want to sell it. So what they're going to do is kind of manipulate this reaction by causing a stress. So we learned the rule about stresses is if you add, let's say I add some N2, now I have lots of ingredients for the forward reaction. If I add, the reaction is going to shift away from what I added so that that reaction dominates. So in this case, the forward reaction would dominate. Now we're going to add to that and say, okay, well, what happens when the forward reaction dominates? Well, that's going to be really good for ammonia because if the reaction is shifting towards you, that kind of means you're being made. That's how I think of it. So if you're being made, your amount is going to increase because the reaction is shifting towards you. So if they said like, what would a reaction shifting right do for ammonia? You'd say it would increase it because it would be making it. Let's say, well, what happens to, so this is increasing, what happens to little old H2 over here then? Okay, what's happening to it? Well, if you have lots of N2 reacting to do lots of this reaction, H2 is kind of like getting used up. Okay, so the thing that the arrow is kind of pointing like away from isn't being made, it's getting used up, so it is decreasing. Right? And that's something you have to know. So first you figure out add away, take away towards, is a shift right or left, forwards or backwards. And then you're going to say, okay, if the arrow is pointing at you, you're getting made. If the arrow is pointing away from you, you're kind of getting used up to make something else. Okay, so let's practice. N2 and H2 are getting together to make NH3. But at the same time, the reverse reaction is happening, so I'm also going to put an arrow and say that they're also going the other way. So let's say what happens if you add some N2. So that's going to be our stress. Okay, so let me do that. All right, more N2, add away. And remember, this is shifting one way or the other. You can't like, sometimes people like, it'll be like add away over here. That's to nowhere. You got to either go this way or this way. So the rule is add away. So I'm like, okay, the reaction is shifting to the right. So I could say either right for my shift or forward for my shift. And then I'm going to say, well, what happens to everyone? Well, I'm not going to say what happens to N2 because we said we're increasing it. H2 is getting used up, so it's there's going to be less of it. NH3 is getting made, so there's going to be more of it. All right, let's try another one. Let's try, what if you remove some N2? All right, so take away. And my rule about take away is that the reaction will shift towards it to make more of it. Okay, so the rule is take away towards. So now I know my reaction is shifting left, or that's also called backwards, right? Because we read left to right. So it's shifting backwards. Now what's happening to everybody? Well, I'm not going to address what's happening to N2 because that was my stress. I made it be less. So what's happening to little old H2? Well, now the arrow's pointing at it, so I think it's being made. What's happening in NH3? The arrow's pointing away from it, so I think it's getting used up, decreased. So the thing is, you have to first figure out which way does it shift, left or right, and then what does that say for everybody else? Are they getting made or used up? Made and increasing, used up and decreasing. Let's try one more. If I add some, let's try, add some H2. Okay, I've got more of this, add, so the rule is I've got plenty of H2, so this reaction is going to dominate. I'm going to add away. My reaction's shifting right. So I figured out which way the reaction shifts first. So all these problems are 2 steps. First, I figure out the reaction shifts right. Then I say what happens to everybody. Well, it looks like NaH3 is being made. So I'm going to